space lanes of laser beams emitting conscious signals throughout the galaxy, and unfortunately, we as humans are not smart enough to understand it. Andromeda, our galactic neighbor, we can observe it in our skies without a telescope, which is interesting. However, things have gone from interesting to disturbing and alarming. Michio Kaku has revealed that the James Webb Space Telescope has picked up disturbing signals coming from Andromeda, and these signals turn out to be much more dangerous than could have ever anticipated. Join us on this journey to discover the truth behind these alarming signals and how the future could be far more terrifying than we ever imagined. Andromeda is a cosmic giant with fascinating characteristics that distinguish it in the vast universe. Also known as Messier 31 or M31, it is the largest galaxy in our region with an impressive diameter of approximately 220,000 light years, a true celestial wonder in terms of its cosmic magnitude. Although the Andromeda Galaxy lies at a considerable distance from Earth, approximately 2.5 million light years away, its position in the cosmos places it beyond the limit of our galactic neighborhood. Although its size may be frightening, it is also fascinating to observe its structure. Andromeda shares a similar structural design to our own Milky Way galaxy, with a barred spiral configuration. This feature is highlighted by a central bulge of matter surrounding a flat disk containing stars, gas, and cosmic dust. Its symmetrical structure shows the impressive complexity of this galaxy. In terms of its stellar population, Andromeda is home to an extraordinarily 1 trillion stars, far exceeding the number of stars in our own Milky Way galaxy, which has about 250 billion stars. This explains why it is so visible from Earth, since its brightness is certainly greater. However, the grandeur and luminosity of a galaxy are not the only intriguing characteristics it possesses. Open space hides many secrets, and each galaxy has different and surprising peculiarities. At the core of the Andromeda Galaxy, a concentrated bulge of matter stands out in the spiral structure of the galaxy, illuminating a distinctive appearance. This central bulge is believed to contain a high concentration of stars influenced by the gravitational pull of the galaxy itself. Given that the galaxy has an abundance of stars, it is not surprising that a percentage of them clustered together to form this bulge. In addition, there are more than 400 globular clusters scattered throughout the Andromeda Galaxy, which are spherical collections of stars bound together by gravity. So, despite being an immense galactic beast, the Andromeda Galaxy is not alone in space. In fact, it has an entourage of at least 14 known satellite galaxies orbiting around it, forming a fascinating cosmic family. The interactions between the main galaxy and its satellites play an important role in the formation of their respective structures and evolution, contributing to the rich diversity of cosmic phenomena in the Andromeda system. The presence of a ring of dwarf galaxies surrounding Andromeda has been discovered. These dwarf galaxies are relatively small and faint compared to Andromeda and the Milky Way. The finding of this ring suggests the gravitational interaction between Andromeda and these dwarf galaxies, indicating the dwarf galaxies are under the gravitational influence of Andromeda, probably due to the immense gravitational force of this galaxy. The ring of dwarf galaxies is a subject of active research, as the exact nature of this interaction and the mechanisms that led to the formation of this ring are still under study and analysis by scientists. To advance our understanding of galaxies, dark energy, and star formation, including the Andromeda Galaxy, two powerful instruments are being used: the James Webb Space Telescope and the Dark Energy Spectroscopic Instrument. These instruments play a crucial role in the study and analysis of cosmic phenomena, allowing the mysteries surrounding the Andromeda Galaxy and its stellar environment to be investigated with greater detail and precision. The James Webb Space Telescope is considered the most powerful telescope ever built, and it is designed primarily to observe the universe in the infrared spectrum of the electromagnetic spectrum. This feature allows it to study the first galaxies forming in the early universe by detecting the faint light emitted by these distant galaxies. The James Webb Space Telescope's goal is to provide valuable insights into the formation and evolution of galaxies, including the Andromeda Galaxy, and its observations will contribute to our understanding of the processes that have shaped the universe over time. On the other hand, the Dark Energy Spectroscopic Instrument, or DESI in short, is an instrument specifically designed to study dark energy and galaxy. DESI uses optical spectroscopy, which consists of breaking down galaxy light into its different wavelengths to analyze spectra of millions of galaxies. Through this massive spectroscopic study, astronomers can measure the distances to galaxies and obtain information about their properties, such as their chemical composition, formation history, and motion. DESI's analysis of the distribution and motion of galaxies sheds light on the enigmatic nature of dark energy, a mysterious force that drives the accelerating expansion of the universe. In the specific context of the Andromeda Galaxy, DESI observations have provided fascinating insights into the migratory history of stars within it. By analyzing the spectra of individual stars, DESI can reveal information about their chemical composition and origins. This allows astronomers to trace the history of stars' formation and follow the movement of stars within Andromeda. By learning more about stellar immigration patterns, scientists gained a better understanding of the formation and evolution of the galaxy, as well as its interactions with neighboring galaxies. In addition, recent studies have provided compelling evidence for the existence of a stellar halo in the Andromeda Galaxy that bears similarities to that of our own Milky Way galaxy. This discovery has illuminated the dynamic nature of galaxies and the intricate interactions between them. Observations and simulations suggest that a significant number of stars found in the outer regions of Andromeda's stellar halo have migrated from small satellite galaxies that were gravitationally captured by Andromeda. Over time, several dwarf galaxies merged with the Andromeda Galaxy, taking their stellar populations with them. This process of galactic cannibalism is known as galactic accretion or merger. Galactic mergers are believed to be common in the universe and shape the structures and characteristics of galaxies, including Andromeda. The presence of stars from other galaxies resulting from interactions and mergers with smaller companion galaxies helps researchers understand the kinematics and distribution of stars in the stellar halos of galaxies such as Andromeda and the Milky Way. By studying the populations of stars in these stellar halos, astronomers can trace the history of galactic mergers and interactions that have shaped these galaxies over billions of years. The stellar halo contains stars that have been absorbed by smaller satellite galaxies or star clusters, and their properties can provide valuable information about the history of galaxy merger and assembly. This galaxy merger process has been a key factor in the evolution and formation of galaxies such as Andromeda and has contributed to the diversity of features and structures observed in them. Through detailed observations and computer simulations, scientists can analyze the chemical composition, age, and motion of the stars that form the stellar halos. These data allow them to reconstruct the time sequence of galactic mergers, identifying the progenitor galaxies that will contribute to stellar populations and understand the physical processes involved in such mergers. Now, this approach is of utmost importance because if this massive galaxy will ever come into contact with our own, it will be crucial to be prepared with all available knowledge. For years, our understanding of the Andromeda Galaxy was based solely on observations from Earth. However, thanks to technological advances and the launch of the James Webb Space Telescope, we have considerably expanded our knowledge of it. We are now at a turning point as the telescope has detected disturbing signals coming from Andromeda, which has generated a great interest and curiosity in the scientific community. These signals have surprised astronomers and sparkled a debate about their meaning and why they are causing such a stir. Until recently, our understanding of the universe was limited by the technology available. For centuries, astronomers believed that the Milky Way was the entire universe. but the discovery of the Andromeda Galaxy radically changed this perspective. This discovery dates back to the 17th century, when Galileo Galilei was a pioneer in revealing the true nature of the Milky Way, showing that it was composed of countless stars. However, it was in the 1920s that Edwin Hubble, using the Hooker telescope, discovered galaxies beyond the Milky Way, including Andromeda, marking it a milestone in our understanding of the cosmos. This finding demonstrated that the universe was much vaster than previously believed, challenging our conceptions of humanity's place in the universe. The Persian astronomer Al-Rahman A.I. Sufi was the first to observe the Andromeda Galaxy around the 10th century, thanks to the technological advances of its time. However, it was in the 20th century that astronomers really began to understand the true nature of Andromeda. This galaxy is a vast nebula cloud composed of stars similar in structure to our own Milky Way galaxy. It is located at a distance of approximately 37 million light-years from us. Since the discovery, the way we study Andromeda has evolved enormously. We have moved from relying on observations from Earth to using space telescopes such as Hubble and the James Webb Space Telescope. Each technological advance has given us a deeper understanding of the composition and structure of Andromeda, making it a reference point for understanding the formation and evolution of galaxies in general. Understanding the relationship between Andromeda and the Milky Way is believed to be crucial to better understanding the universe as a whole. In fact, these two galaxies are expected to collide in about 4 billion years. Recently, the James Webb Space Telescope has detected a disturbing signal coming from Andromeda, puzzling scientists around the world. These signals suggest unusual activity in Andromeda's core, possibly related to its supermassive black hole or other important phenomena within the galaxy. Furthermore, new discoveries indicate Andromeda's mass could be much greater than that of the Milky Way galaxy, which has significant implications for the evolution and dynamics of both galaxies. Detailed images and spectra provided by the James Webb Space Telescope has revealed information of new stars and the chemical composition of Andromeda, providing valuable information for understanding the evolution of galaxies and the conditions for life in the universe. Data collected by the telescope indicates a notable increase in activity in Andromeda's active galactic nucleus, which has impacted its surrounding environment and is expected to shape its future structure. This increase in activity has also revealed gravitational effects on Andromeda's stars, suggesting the presence of dark matter throughout the galaxy. Understanding this phenomenon is crucial to understanding the cosmic dynamics at play. The James Webb Space Telescope has motivated a series of studies around the world as scientists explore the mysteries of Andromeda with additional information. Through these studies, we have gained a clearer view of the past and future of this impressive galaxy. Andromeda stands out for its unique characteristics that distinguish it from other galaxies in the universe. With an estimated diameter of around 220,000 light-years, it is positioned as one of the largest galaxies in the local group, surpassing even the Milky Way galaxy. This immense scale contributes to its mass, which is estimated at 1 trillion stars, thus outnumbering our own galaxy. Andromeda's structure is also fascinating. Unlike a typical spiral galaxy, it has a dense core surrounded by rings of dust and gas, which provide an environment conducive to star formation. In addition, its core presents a double peak that suggests the presence of a supermassive black hole, similar but different to that of the Milky Way galaxy, providing valuable information about the nature and activities of these massive objects. The galaxy is enveloped by a sphere of stellar debris, including planetary stars and globular clusters, and which tells a fascinating story about the origin and evolution of Andromeda. The 460 globular clusters present in Andromeda offer a unique window into understanding star formation and the early development of the galaxy. By unraveling the mysteries of Andromeda, astronomers are one step closer to understanding the relevance of dark matter in the cosmos and better understanding the processes that shape our universe. However, a question remains about the mysterious nature of Andromeda and the role it plays in galactic dynamics. A distinctive feature of Andromeda is a set of satellite galaxies, forming its halo structure with more than 20 smaller galaxies. Some of these galaxies are experiencing the tidal effect, which implies that Andromeda is absorbing and destroying these smaller galaxies. This active process is revealing how galaxies grow and interact over time, shaping the future of Andromeda and its direction of motion. The possibility of Andromeda becoming a ring galaxy is strategic in its evolution. The evidence points to a process that could involve galactic collisions or interactions with other galaxies. The imminent collision with the Milky Way galaxy, estimated in about 4 billion years, marks the birth of a new galaxy from these two giant entities. Although destructive, this collision is a natural process in galactic development, which will result in the formation of a new elliptical galaxy. The merger of supermassive black holes in the core of both galaxies adds more mystery to the celestial event, suggesting a complex cosmic evolution. This merger is expected to produce explosions of matter engulfed by the black holes, releasing extensive radiation and providing important data on galactic evolution. The crucial question of what will happen to our solar system after the merger of Andromeda and the Milky Way galaxy involves possible significant changes in the orientation and conditions of the solar system. This could affect the stable orbits of stars, including our Sun, and dramatically alter the climate on Earth. The merger of Andromeda and the Milky Way illustrates the complex relationship between celestial bodies and how they evolved over time. Deep in the immensity of the cosmos, 2 million light-years away from our galaxy, we find Andromeda, the closest galaxy to us. Considered one of the most beautiful galaxies, on a completely clear night we could observe it with the naked eye due to its relative proximity. It has an immeasurable number of luminous stars like ours that could contain life right now. Apparently, this galaxy is not as beautiful as we thought, and we could be facing a terrifying galaxy formed by the entire destruction. What is the reason for this? Stay with us until the end of the video to find out, and remember to like and subscribe. This way you'll be supporting the channel, and that helps us a lot. It is known that galaxies are formed by stars that from their beginnings were formed by gas and dust, products of the Big Bang. Little by little they adapted their shape until they took the place we all know in this immense universe. However, it seems that our nearest neighbor is a cannibal monster galaxy, which during its long time of life has been devouring smaller galaxies. Now comes for us to cause a huge galactic collision, or perhaps with the aim of slowly devouring us until we are a single galaxy. As it grew, the Andromeda Galaxy became a cannibal galaxy that devours its weaker neighbors, and this will happen with the Milky Way. Andromeda leaves cosmic crumbs in its wake and has done so for billions of years. According to a study by the University of Sydney, Australia, there is a high probability that the Milky Way will suffer the same fate. The first related phenomenon was observed by a reputable team of astronomers from Australia who were studying the Duckley structure. This structure inhabits the Andromeda Galaxy but appears to have originated in another galaxy. This leads researchers to think that perhaps it had been devoured by a cosmic colossus, and for this reason, astrophysicists describe this team of stars as the work of a cosmic feast that Andromeda had at some point in history. It seems that this is not the first time that this has happened throughout history. It is that the insatiable gravitational pull of Andromeda has finished in the same way with small galaxies, and from these observations, scientists determined that the growth of Andromeda had been violent and sporadic. This could explain why smaller objects orbit Andromeda's outskirts and could be the remnants of its various cosmic feats that the galaxy has had in the past, at different times of its development in the universe. This process has already begun for us, and both structures are approaching each other at 400 kilometers per hour, according to a document provided by NASA. Although this speed is imperceptible to humans, this marks the irremediate path for the formation of Andromeda, the new galaxy that will be formed from the merger between the Milky Way and Andromeda. Astrophysicists estimate that the collision will occur in about 4 billion years, and it is believed that when our cosmic neighbor hurtles towards our galaxy, a giant elliptical structure will form. Andromeda will not devour the Milky Way. On the contrary, they will unite to form a much larger, complex, and harmonious structure, but unfortunately, human beings will be completely extinct by then, and only remnants of a civilization that once existed in this universe will remain. Or maybe not. Maybe we humans will develop enough to not have to suffer this mega cosmic collision that would end our existence. We're going to be ambiguous and we are not going to think about what to do in 100 years. But in thousands and millions of years, we're going to manage to escape, not only from our solar system, but from our galaxy. Nobody can confine our imagination. In millions of years, we will be close to immortality and we will be able to withstand the radiation of outer space and travel at speeds like the speed of light. What a breakthrough it would be for humanity to have some advanced technology to allow us to pivot between galaxies in order to save our race and thus be able to continue expanding to observe from our world the incredible collision between the Milky Way and Andromeda. Today, for us, the residents living in the Milky Way, this collision would be a natural catastrophe because it would kill us mercilessly. But in the case of being able to pivot to another habitable world outside these two galaxies will allow us to save our existence, and from our sky, we could observe this mega collision, which a priori may seem terrifying because it touches us directly, but watching it from another world outside these galaxies must be a wonderful spectacle. When this merger takes place, Andromeda will be orphaned of life for millions and millions of years, but it will not be forever. When the miracle of life happens again in this new galaxy, the inhabitants of Andromeda will live many years longer than us. However, they will have much to envy us for. Since new stars will no longer form, they will not be able to contemplate these beautiful shapes and colors of this region where it happens. Nor will they have the opportunity to know the details of the Big Bang, since the radiation that has allowed us to observe the first moments of the universe will not be visible to them. They will not be able to observe the first galaxies formed or the quasars, which means that they will not be able to learn about the expansions of the universe. In fact, even the light coming from the nearest galaxies will become fainter and fainter, and there will come a point where this civilization will only see a single galaxy, their own. They will think that the universe is static and eternal, thus returning to the early views of the Aristotelian universe, where it was believed that the Earth was the center of the universe and that the Sun, the Moon, the planets, and all the fixed stars revolved around our Earth. The Aristotelian model was of great importance in the development of human thought, not only because it remained for a long time as a paradigm or way of understanding the world in the history of our civilization, but also because without knowing it, the process of paradigm shift initiated by Copernicus cannot be understood. The Aristotelian model, also known as Aristotelian philosophy or the Aristotelian system, refers to the philosophy and theories developed by the Greek philosopher Aristotle, 384 to 322 BC. Aristotle was a disciple of Plato, and his work covered a wide range of disciplines such as logic, metaphysics, ethics, politics, biology, and physics. It's based on a theological conception of the universe, which means that it considers everything in nature to have an intrinsic purpose or finality. According to Aristotle, the ultimate goal of all things is to reach their full potential or perfection. For example, the goal of an acorn is to become an oak tree, and the goal of a human being is to attain wisdom and happiness. In terms of logic, Aristotle developed a rigorous deductive system known as Aristotelian logic. He introduced the concept of syllogism, which is a type of deductive reasoning composed of true premises and a conclusion. Aristotle established rules and principles for the validity of syllogisms and classified the different forms of reasoning in his work, Organon. In metaphysics, Aristotle proposed a theory of substance and causality. According to him, everything in the universe is composed of individual substances, which are entities with independent existence. In addition, he identified 4 causes or grounds for the change and existence of things: the material cause, the formal cause, the efficient cause, and the final cause. In Ethics and Politics, Aristotle argued that the supreme goal of human beings is to achieve happiness through virtue and moral excellence. According to him, happiness is achieved by living in accordance with reason and balance, following the middle ground between extremes. He also presented a political theory known as Aristotelian politics, in which he advocated a form of government based on virtue and the common good. Thank you so much for watching the video. Remember to give a like if you liked the video and subscribe. This way you'll be supporting the channel and help us a lot. See you in the next video.